Bismillahirrahmanirrahim. This is a continuation of previous lecture. In previous lecture, we have seen that we had an equation that was equals to Vc of t in voltage across a capacitor that was equals to V naught minus Va over 1 minus alpha R Thevenin time capacitance multiplied by e raised to power minus t over RC, R Thevenin time C, and plus Va over 1 minus alpha R Thevenin time C into e raised to power minus alpha t, and of course this is in voltage. So this is a long equation, and I don't think it is easy to memorize, or so we must have some easy solution or easy way to understand or memorize this equation. So what we'll do, we have this capacitor voltage V of t, C means capacitor voltage. So what is V naught? V naught is basically the start value, mean initial voltage of capacitor if that was start. So we have this start voltage, start value minus forced value at time t is equals to 0 multiplied by e raised to power minus t over tau plus forced value at any time. So if you memorize this phrase, or even the more simple phrase is coming in the next equation, so we can memorize this equation. So what is the value of Vt? Again, V naught minus Vf at 0 in force value into e raised to power minus t over Rc plus Vf in force function at any time. So what is the value? What is V naught here? V naught, you already know that initially capacitor voltage, and tau is R Thevenin times C. And what is Vf? This is a thing that you should know or memorize, and that is Vf of t, that is force response when the input is exponential, and of course that will be equal to same as input. And what is our input? That is kf e raised to power minus alpha t. So, and you know that from previous lecture, your kf is equals to Va, mean its maximum voltage, 1 minus alpha R Thevenin times C. So this is basically equals to Vf at times t is equals to 0. So even more easy to understand, you remember one phrase, that is initial minus forced at 0 times natural decay. And what is the natural decay? That is e raised to power minus t over tau. This is the natural decay, plus forced decay. And what is a forced decay? That is e raised to power minus alpha t. This is a forced decay. Now again, we will write our equation. So this is Vt is equals to V naught minus F naught e raised to power minus t over tau. Tau means Rc, plus F naught e raised to power minus alpha t, where F naught is equals to Va over 1 minus alpha R Thevenin times C, and tau is equals to R Thevenin times C. Now this is very easy to understand this equation, as you have already understood previous in the previous lectures. That was equals to V naught minus V at 0 minus, I just write in a small, that was V at 0 minus V at infinity multiplied by e raised to power minus t over tau plus V at infinity. This was for first order differential equation, and that was equal to some force function. Similarly, we have this equation written in green, V naught minus F naught multiplied by e raised to power minus t over tau plus F naught e raised to power minus alpha t. This is easy to understand, and you just know what is the value of F naught, and this is equals to Vf at 0. Now here we have a numerical example in which we will understand how we apply these relations to get our required result. So we have a circuit such that this is a potential source having value some Vs, again a function of time, and here is a resistance of 300 kilo ohms, and the second resistor that is of 200 kilo ohms, and there is a capacitor of 0.001 microfarad, such that you need to find out the value of this IC of t, and you need a value of this Vc of t in voltage across the capacitor. Now the value of source, that is a function of time, is given to you, and that is 100 e raised to power minus 1000 t. And here you can see that from this equation your alpha is equals to 1000, And by applying R Thevenin, we will short this voltage source and open this capacitor from this point. We get R Thevenin. Here we have two resistor, 300k, that is parallel to 200k, and very easy to calculate. 300 inverse plus 200 inverse and whole inverse. So we get the value of 120 kilo ohms. And we already know the value of capacitor, that is 0.001 microfarad. So we get the value of tau, that is R Thevenin times C, and this is equals to 120 into 10 raised to power 3 multiplied by 0.001 10 raised to power minus 6. So this will be equals to 120 microseconds. Now we will write our equation that you have seen in your previous lecture. Even in this lecture, your voltage across capacitor, this is equals to V naught minus Kf, or you can write F naught. Your book says Kf, so just write Kf. E raised to power minus t over tau plus this Kf. Now, what is the value of Kf? Your Kf is equals to Va over 1 minus alpha R Thevenin times C. Now, Va is given here. This one is basically Va. But you need to find out the value of V Thevenin, because we have transformed everything into Thevenin equivalent. So again, you have to draw a new diagram such that this is your V Thevenin times T, and this one is your resistor. You have calculated this one is equals to 120 kilo ohms, and here you have a capacitor of 0.001 microfarad. So you need to find out this IC and this plus minus Vc of t. So to calculate the value of VThevenin, to evaluate the value of VThevenin, we have VThevenin that is equals to voltage across this resistor. So you have 200 divided by 200 plus 300 multiplied by 100 volts. So that will be equals to 40 volt, and plus e raised to power minus 1000 t. This is complete voltage equation. Now again, we will find out the value of Kf now. So Kf will be equals to V Thevenin over 1 minus alpha times R Thevenin times C. So what is the value of Va or V Thevenin? That is 40 divided by 1 minus alpha. Alpha is 1000 multiplied by the value of RC times C. And you have already calculated this 120 into 10 raised to power minus 6, because this one is in microseconds. So you get the value of Kf, and this is 45.45 volts. Now you have all the values now. Now I will write in this equation. So V C of t, this will be equals to, first of all, again, sorry, we haven't find out V naught 0 initial voltage. As you can see that this is a function of time, and Vs of t, and this one was into U of t. It means that the voltage exponential is basically the voltage is 0 before time t is equals to 0, and after that some voltage are coming, voltage are appearing. So it means that your capacitor was initially at 0 volt. So V naught at 0, V naught at 0 time means 0 negative, that is equals to 0 volt. This is important thing to calculate. So replacing all the values here in this equation. So Vc of t, that will be 0 minus, what is the value of Kf? That is 45.45 e raised to power minus t over 120 microseconds, plus what is the value of Kf here? Again, you know that 45.45 e raised to power minus 1000 t. Now rest of things are now only calculations. So we have 45.45 e raised to power minus 1000 t minus 45.45 e raised to power minus 8333 t, as 1 over 120 microseconds is equals to 83. Now this is equals to volts. Now the second part of the question, to find out this value of IC, and you know that if you have the value of Vc of t, this was Vc of t, and if we take IC is equals to C dV ct over dt. So we'll take the derivative of this whole term and multiply it by capacitance value, so we get the final answer. So let's do it. So what is the value of capacitor? So that is 0.001 into 10 raised to power minus 6 multiplied by d by dt of 45.45 e raised to power minus 1000 t minus d by dt of 45.45 e raised to power minus 8333t, and this whole multiplied by 0.001 into 10 raised to power minus 6. So 0.001 into 10 raised to power minus 6 multiplied by 45.45 e raised to power minus 1000 t, and multiplied by minus 1000 minus 0.001 into 10 raised to power minus 6 multiplied by 45.45 into minus 8333 multiplied by exponential minus 8333t. Now, by solving this numerical values, what we get? We get minus 45.45 e raised to power minus 1000t, this whole thing, plus this negative sign and this negative sign, this will become positive, plus 379 e raised to power minus 8333t, and this whole into 10 raised to power minus 6 that we can write in this whole value in write in micro microampere. So this is how we calculate current and voltage of a circuit having forced exponential waveform. So in preceding lecture, we will calculate if the input function is sine function or cosine function. So that will be our next target, and then we will solve a relative example of it. Thank you very much. See you in next lecture.